You think Niagara Falls is just water falling? Then explain this. Its thunder is legally scheduled. Its height is a trick question. And once, it basically stopped. Stay till the end, because fact number 13 is the creepiest silent story in waterfall history. Niagara has a tourist mode. By treaty, minimum scenic flow is regulated. 100,000 cubic feet per second in key daytime hours, 50,000 at other times. Yes, Niagara has a schedule. During peak tourist hours, more than 168,000 cubic meters per minute pours over the crest. That's not a waterfall. That's a moving water factory. People argue about the American Falls height because it depends what you mean by drop. To the top of the rock pile, it's often quoted around 70 or 110 feet. Crest to river is about 188 feet. That rock pile at the bottom, it's not random. It changes the plunge profile and how the falls looks over time. Niagara isn't a statue, it's a living erosion machine. Upstream rapids can hit about 25 m/s, and maximum speeds at the falls have been reported up to 68 m/s. That's water moving like a vehicle. Below the drop, the river doesn't relax, it attacks. Whirlpool rapids can reach around 30 m/s, and Devil's Hole Rapids around 22 m. The deepest part of the Niagara River is right below the falls, about 170 feet deep. Imagine standing on a bridge above a river, as deep as the falls is tall. Niagara has moved about 7 miles in roughly 2,500 years, carving the Niagara Gorge as it goes. Waterfalls don't just fall, they travel. After the glaciers, water didn't choose one path. It took 5 spillways from Lake Erie to Lake Ontario, then slowly consolidated into a single dominant Niagara Falls. Here's the wild part. Erosion isn't only grinding. Niagara also uses cavitation. Tiny bubbles collapse near rock, sending shock waves that can help break bedrock. Nature's micro-explosions. That green glow? Niagara carries about 60 tons of dissolved minerals per minute, plus ultra-fine rock flour. The color is chemistry plus crushed geology. People ask, why doesn't it freeze? Because the volume and speed keep it moving. You can get ice, massive ice, but a full solid freeze is extremely unlikely. But it did stop once, 1848. An ice jam upstream drastically reduced flow, parts froze, and witnesses described an eerie silence for hours. Imagine standing here and hearing almost nothing. In winter, an ice bridge used to form and people even crossed between the USA and Canada, until a deadly collapse in 1912 ended that era. Niagara isn't isolated. It's the channel connecting Lake Erie to Lake Ontario, serving ecosystems, industry, recreation, and water needs across the region. Water is diverted above the falls and returned below to generate power. On the Canada side, Sir Adam Beck stations are huge. Beck Y 548 Mendalu. Beck II 1,499 Mendalu. There's an international control dam, basically a weir, helping manage flow and diversion between Ontario Power Generation and the New York Power Authority under treaty rules, monitored by the International Commission. That scenic flow treaty math is so formal, it's published in metric too. 100,000 CFS, 2,132 N3LS, and 50,000 CFS, 1,416 M3LS. Before the big drop, the river splits around Grand Island, creating separate channels. like the river is choosing lanes before it hits the edge of the world. Niagara isn't the tallest waterfall on Earth, but it's one of the most unforgettable because it combines serious height with a massive, controlled volume, a roaring wall you can feel in your bones. Now tell us, which fact shocked you most? 1. The roar is scheduled. 1. It stopped in 1848. Or 3. Bubble explosions smash rock. Comment number 1, number 2, number 3, and if you want, top 20 geofacts, Grand Canyon next.